we solve a second example. And that is a of k is equal to k squared minus k. So for the first step, we count the number of terms. So we have two terms, k squared and negative k. For the second step, we add 1 to the number of terms to consider the constant term plus 0, or in general plus c. For step 3, we write the three equations. So these are a of k is equal to k squared minus k. The second equation, a of k minus 1 is equal to the quantity k minus 1 squared minus the quantity k minus 1. That would give us, if we expand, k squared minus 2k plus 1 minus the quantity k minus 1. Solving this further, that would give us k squared minus 2k plus 1 minus k plus 1. We rearrange the terms, k squared minus 2k minus k plus 1 plus 1. So that would give us k squared minus 3k plus 2. Then for the third term, or the third equation, a of k minus 2 is equal to the quantity k minus 2 squared minus the quantity k minus 2. We expand the quantity k minus 2 squared, that would give us that equation. And then solving this further, that would give us k squared minus 4k plus 4 minus the quantity, or minus k plus 2. So we rearrange again the terms, that would give us that equation. So solving this, k squared minus 5k plus 6. So we now have the three equations. So writing this for step 4, we now have to solve the systems of equations. So that is the first equation, the a of k, then the a of k minus 1, and the a of k minus 2. So with these three equations, we can now solve for the recurrence relation. So for the next step, we want to eliminate k squared using equations 1 and 2, and we subtract 2 from 1. So that will give us a of k minus a of k minus 1 is equal to the quantity k squared minus k minus the quantity k squared minus 3k plus 2. So that will give us the quantity k squared minus k minus k squared plus 3k minus 2. So we continue solving and we get k squared minus k squared minus k plus 3k minus 2. So k squared minus k squared is 0. So we are left with negative k plus 3k minus 2. So negative k plus 3k is 2k minus 2. That would be our equation 4. Then we also want to eliminate again k squared using equations 2 and 3, wherein we subtract 3 from 2. So we now have a of k minus 1 minus a of k minus 2. That would give us that equation for the right hand side. So if we continue solving this problem, we will end up with equation 5, which is equal to 2k minus 4, as shown in the solution. So with this, we now have 5 equations. So the next step now is we have to eliminate k using the equations 4 and 5. That would give us the quantity a of k minus a of k minus 1 minus the quantity a of k minus 1 minus a of k minus 2 is equal to the quantity 2k minus 2 minus the quantity 2k minus 4. Then we solve first for the left hand side. That would give us a of k minus a of k minus 1 minus a of k minus 1 plus a of k minus 2 is equal to the quantity 2k minus 2 minus the quantity 2k minus 4. Then we continue. That would give us a of k minus a of k minus 1 minus a of k minus 1 plus a of k minus 2 is equal to the quantity 2k minus 2 minus the quantity 2k minus 4. We add the two terms. That would give us a of k minus 2a of k minus 1 plus a of k minus 2 is equal to the quantity 2k minus 2 minus the quantity 2k minus 4. Now we solve for the right hand side. That would give us the quantity 2k minus 2 minus 2k plus 4. Solving this further, that would give us 2k minus 2 minus 2k plus 4. Next step, we have to subtract 2k minus 2k. That would give us 0. So what is left is negative 2 plus 4. That would give us 2. So we copy the left hand side. That would give us a of k minus 2, a of k minus 1 plus a of k minus 2, where the value of k is greater than or equal to 2. We now have the recurrence relation for the closed form expression k squared minus k. So that's it.